Okay, so let's do a bit more of a complicated frames example. So we got this one here. So this is a structure that is made up of a number of components, 4 of which are 2-force members and 3 of which are multi-force members. So our 2-force members are AF, BG, GD, and EH. And then our multi-force members are ABC and CDE. Multicolor, multi-force. So we're looking for the reactions of the supports and then the nature of the forces in the links. Okay, so to start off, redrew this sucker here. So we've got some load applied P. It's applied at this joint here that's B. And then these distances are all A. So, yeah, as mentioned, we identified which ones were 2-force members. It's the ones that are pinned and don't have anything kind of attached in the middle there. So I went and drew a free body diagram of the overall frame. Again, if we start with our default assumption that the 2-force members are under tension, then essentially in order to do that, we'll need to be pulling on the 2-force members to cause that. The supports would have to be doing that. So we'll be pulling on them like this. So we got our force here, force GA, force HD, force BH, and force EI that we don't know. Well, that's a problem now, isn't it? So that's a problem because we got 4 unknowns, and we got only 3 equations to solve solve those unknowns with. We're going to be hitting a stop if we just focus on the overall frame itself as a rigid body, which doesn't mean that we can't get some useful information out of it. We still can. We just can't solve the entire thing just doing that. So we'll start with that at least. Just doing the sum of the forces in the x direction. That just means that we got cos 45 of the BH. So that's saying that this component here minus cos 45 of HD is 0. So therefore, we now know that the forces in those 2 links are going to be equal to one another. Still don't know their magnitude, still don't know their sense, still don't know their in tension or compression, but whatever it is that they are, they're the same. And then next up, we can just sum the forces in the y direction. So we can go ahead and just sum forces in the y direction is 0. So we got minus our minus FGA. We've got so again I'm using this property right here already. So we got the negative component of FBH and the negative component of FHD. So they're the same thing, and the negative components are acting in the same direction. So we'll just have double that. So again, that's sine 45 FBH. I decided to work with FBH. We're tossing FHD out for the time being. Everything will be in terms of FBH. And then minus our FBI and minus our load as well. Can't forget about our load. So that's simple enough. Just plugging in the numbers for FBH there. Negative 1.414 That's negative 2 sine 45. So we got that, and we can also take a moment that might give us some decent information. So I just take a moment about FEI. Again, the combination of these two give us a negative force of give us a force in the in the downward direction of 2 sine 45 FBH, and those a downward force there acting at from here to here is 2a, gives us 2a times 2 sine 45 FBH, which when we plug it when we do the calculations there ends up being and again that's a positive moment. It's going to be measured from here. It's going to be acting counterclockwise, so it's a positive moment. Got a negative force crossed with a negative displacement vector, gives us a positive moment. It also got 3a times p, so again, same deal, negative force, negative displacement of 3a from here to here, and then just 4a from here to here, in order to give us our 4a FGA, and then I just, cancel out all the a's, cross those out, divided by a, they go away. And that gives us this relationship here. So, all right, that's our three equations if we're just looking at the frame itself as a rigid body. Not all that useful, right? So we're gonna have to do something else. Kind of at a dead end at this point. So what we can do here is we can look at a free body diagram of the links themselves, the multi-force members themselves. So if we look at the bar ABC here, that's going to have just the force from GA. Again, it's a tensile force so on the bar the link itself will be pulling on the bar because it's tensile. It'll be pulling down. Same with FBH here. We got the load. We know which directions the load's being applied in. That's P. And then we've got some unknown reactions between this at C here. So that link C there is going to be equal and opposite to the equivalent reaction at the other bar. The one on the ABC one is the one that I drew first, so that's the one I gave the positive values. And then when I do the free body diagram here of CDE, I give it, it's equal and opposite. So just CY is acting negative, CX is acting positive. And again, it may or may not end up being positive or negative depending upon how things work out. And then, D, we've also got the FBH. Again, it's not actually FBH, it's FHD, but those two things are equal, and I want to be working in as few independent unknowns as possible. So the last of the forces we've got is FEI here. And then, so basically, listing off our independent unknowns, got FGA, FBH, got CY, CX, and FEI. We got 6 equations we can use to solve them because we got free body diagrams that we can take of two separate bodies, separate but related, and 5 unknowns. All right, that's not too hard, right? So first, I'm going to start off by taking a moment about B here on the free body diagram ABC. So I'm picking B because it's a spot where essentially a lot of the numbers cancel out. P passes through it, BH passes through it, CX passes through it. So the only things that are going to end up on there is our FGA term and our CY term. Okay, so a moment about there, we're going to have a positive CY times A. The distance between here and here is A. And then we're going to get a positive FGA times A as well. So both of these things are causing rotation in the counterclockwise sense. So both of those are positive. So working from there, just ACY plus FGAA, cancel out the A's, gives us CY is equal to negative FGA. All right, congratulations. We already got rid of one of our independent unknowns. So I'll call that equation 4 here. Next up, well, let's do the same thing on the other side. So taking a moment about D gives us a negative FEI minus A. A negative FEI A. So that's working that way. And then we've got A times CY. So that'll be a positive moment, since the CY acting on this body is going to be pushing downwards, which will, based upon the relationship between where it is located relative to D, will give us a positive moment for CY. So we got CY is equal to FEI, and then we already know that CY is equal to negative FGA, so we got our FEI is equal to negative FGA. All right, congratulations. We crossed off another independent unknown on our list. We're doing well here. So, and then just taking the sum of the forces in the y direction on the bar ABC. Got our negative FGA here. We've got our positive CY here. We got our P here. And then we have negative, the y component of this force. So that is going to be negative sine 45 FBH. So we'll call that equation 7 here. So what we can do is we can take that equation there and we can combine it with one of the ones that we saw previously, this one here. If we take this equation and combine it with, this is equal to 0, and this is also equal to 0. So I'm putting this on the left side of the equation as equal to 0, and then on the other side of the equation, it's also equal to 0. So I'm just sticking that there. But I'm multiplying that by negative 2, just to allow us to. So that gives us this is equal to this, which allows us to kind of cancel out a few things. So if we subtract from both sides of the equation negative 4 FGA, those go away. We can subtract negative 2. We can subtract 2p from each side of the equation. So that one goes away, and that one turns to 1. And then if we subtract 2.828 FBH from each side of the equation, it goes away on this side, and then on this side we got 1.4142 FBH minus the 2 blah blah blah. That just gives us P is equal to negative 1.414 FBH. All right, so we solved for FBH in terms of P. I guess I should have actually written that down explicitly. BH is equal to P over negative, 1.414. So yeah, we got the first actual force of the link, just in terms of P. We're making progress here. So next thing we can do, well, the last thing we do is take the sum of the forces in the y direction on ABC. So let's do the same thing here for CDE. So there, we've just got the negative CY. We've got the negative sine 45 FBH term. And then we've got the negative FEI pulling down here. Got that, and we've got the vertical portion of that little force there. Alright, so we can take that, but we know this in terms of something else, and we know this in terms of something else, so we can plug those in. We got equations 5 and 8. So this one I called equation 5, and this one, this one was 8. So just plugging that into there. So CY is equal to FEI. So we got negative 0 is equal to negative FEI minus sine 45 times P over 1.414 minus FEI. So that ends up actually being, so we basically that gives us when we solve for FEI in terms of P, that gives us P over 4. The sine the negative sine 45 and the negative 0.414, that ends up being just 1 over 2 P over 2. So then we get 2 FEI plus P over 2 is equal to 0. Moving the FEI over to the other side, dividing by 2 again, gives us FEI is equal to P over 4. So, again, we're knocking these off. So we got that solved just directly in terms of P4. And then we can take that, and we can take that relationship there, and we can take this relationship here, and we can plug that into one of the first ones that we had solved for. So equation 2 here. That was just the sum of the forces in the y direction on the frame itself. So taking that, so FGA minus 1.414 FBH minus FEI minus P. So trying to solve for FGA, so we'll leave that alone. But plugging in the FBH is equal to P over 1 P over negative 1.414. Now the 0.414s cancel out. The negative 0.414s cancel out. That just gives us a P term here, which subtracted from another P term. Those two P terms cancel out. And then we have FEI here, a negative FEI here. So that's P over 4, so negative P over 4. Which just, which is our value. Negative 1 over, our FGA is going to be equal to negative P over 4. So as a bit of a sanity check, it's good to kind of go back to original free body diagram, kind of throw stuff in there. So we got our P over 4 term here. I got P over 4 term here. So again, the tension calculated in this one ended up being positive. So the sign, the directionality of this arrow stays the same. For this one here, this one ended up being in compression. So it, in order to compress that link, you need to be pushing on it. So the reaction is pushing on that link in order to compress it. So it has a positive force being applied there at P4. At G. And then we've got our load. And we've got these two forces here. They're equal in magnitude, and they're just acting in different directions. So their magnitude is P over 1.414 or 0.7072 P. Now, just to make it a bit clearer, we got two forces here that are acting. They're equal, and they're acting through the same point. So what we can do is we can kind of just take those and replace those with a resultant, right? So we know that the x components of those two forces cancel out. Simple enough, right? They're equal, and they're pushing up against one another in with the same magnitude. So we only get the combined vertical resultant there. So the combined vertical resultant there, for each of those, is going to be 0.7072 times sine 45. Hey, look, that's 0.4. Sorry, 0.5. That's 0.5 P. Each of these contributes a 0.5 P vertical component to supporting this frame. So the resultant of that force, of those two forces, is just going to be a P acting in the middle there. So looking at this, at a glance, we've got a downward force P, we've got an upward force P, and then we have a P and a P over 4 and a minus P over 4. So from the perspective of the y forces, that balances out. And the other thing we might want to do to see if it works out is just kind of take a quick moment. So I'm going to take a moment about the middle here. So here, the P component is going to be adding a positive moment because about that middle bit there, it's going to cause counterclockwise rotation. So the magnitude of that is going to be P times A. Still got A between each of these frames. A. And then that'll be counteracted by the moments caused by the forces at the other ends. So we got this one here. That one's going to be causing a counterclockwise rotation. A clockwise rotation. And then this one here also going to be causing a clockwise rotation. So that's going to be counteracting the one caused by P. And then the magnitude of each of those. Well, okay, we got for this one, P over 4 times 2A gives us P over 2. PA over 2. And then this other one here gives us the same magnitude, PA over 2. So combine those two and we get PA, which, hey, is exactly the amount that we calculated would be caused by this one. So equal and opposite reactions. So yeah, combine them all, we get 0. So bit of a sanity check after we're done. It works out. We're able to, our overall structure balances out. It's not going to be rotating. It's not going to be shooting off into space somewhere, which gives us a good warm fuzzy that we kind of didn't switch up any of our units, any of our signs along the way, or so on and so forth. So that's about that. Cheers.